Hey everybody, it's Mr. Shrum, and I am back again with some physical science tutorial walkthroughs and some mastery test walkthroughs as well. And we're starting with energy flow today. The flow of energy, and we're going to use a model to explain how energy flows within a system, and then describe the interactions of energy between the four spheres of Earth. And that will all make sense to you in a few moments. But let's jump into the warm-up. Have you ever had days when you feel drained of energy? You might have used the word energy without even thinking about it. We require energy for every process, every movement, and every reaction that comes to mind. Read these questions about energy, think about your answers, and then record your answers in the notebook tool. That would be this button, shaped like this over here. Okay? What is your definition of energy? What do you think of when you hear the word energy? Do you think Earth itself, our planet, uses energy? Why or why not? Do you think energy can be used up? Why or why not? And then after this lesson, let's see how your mind has changed or stayed the same. Maybe you were right all along. But let's get into energy. Energy. We use the word energy in a number of situations. Athletes and people who exercise regularly might eat foods that are quote unquote high in energy. After a long day of school and activities, you may feel like you don't have the energy to do anything else. Energy is what makes things happen around us. In these examples, energy helps you perform some activity. Just as you need energy to perform tasks, different systems require energy to function properly. What is energy? You've probably seen trees swaying to and forth on a windy day. You may have watched documentaries showing volcanic eruptions. Strong winds and erupting volcanoes have one thing in common. Both natural phenomena are caused by energy. So what is this energy thing? How does energy affect all processes on Earth? Well, let's take a deeper look. Energy is the property of an object or system that allows it to do work or cause a change. Now, work, if we click on this definition, work is defined as a change in the energy of an object when a force is applied and the object moves. That is doing work on something. This change can occur in various ways. It can be a change in state, like melting ice, or a change in motion, such as the acceleration of a car. We use energy to throw a baseball. Cars use energy to move down the street. When force is applied to an object, it sometimes changes the object's position. And remember, what force means is a push or pull on an object. If the object does move, it is called work. Think about the last time you visited a supermarket or the grocery store. You can move any of the shopping carts by applying a force or pushing them. And this movement demonstrates work. If the object doesn't move, no work is done. So you apply a force and you're doing work on the cart. That's how we phrase that in physical science. We have kinetic energy, the energy an object has because of its motion. Any moving object will have some kinetic energy. And the amount of kinetic energy depends on its speed and mass, the velocity and mass. For instance, swinging the same golf club fast rather than slow raises the kinetic energy of both the club and the ball once the ball has been struck. Think about throwing a big stone and a small pebble into a river at the same speed. The pebble creates a smaller splash than the big stone does. The pebble has less kinetic energy because overall it has less mass. Kinetic energy is the energy an object has because of its motion. Any moving object will have some kinetic energy, and that depends on the speed and mass, like we just said. For instance, we talked about the golf club swinging faster rather than slower, and the big stone and small pebble into a river. And I think they just copied that. Oh, and now we're talking about potential energy. Excuse me. That potential energy is the energy stored in a body or an object. Think of body as in an object, a thing. For example, a book placed on a ledge, a brick held above the ground, and a stretched rubber band each have potential energy. Potential as in energy that can be converted into another type of energy. So the potential energy in a rubber band is increased if you stretch it further. And if you take a brick and then raise it higher off the ground, that increases that potential energy. And the potential energy can be released, and that can take different forms. And we'll look at that later as well. We've seen the relationship between two types of energy. We have kinetic and potential energy. Potential energy is stored energy based on the position of an object, and there are several different sources for potential energy. Let's take a look at some potential energy. You have potential gravity, gravitational potential energy. If you lift an object up, the gravity pulls down on that object, and you are increasing the potential stored energy of that object. This form of energy depends on the mass of an object and the distance between the object and the surface of the Earth. As the distance from Earth or the mass increases, gravitational potential energy increases as well. Chemical potential energy, that's related to the atomic structure of chemicals. So deep within chemicals, we have the atoms and how they are structured. These substances have the potential to release energy during chemical reactions. For example, the food you eat has some chemical potential energy in the form of glucose. This energy is released in the body and then used to perform different bodily functions. Elastic potential energy, like a rubber band, when you stretch an object, it gains elastic potential energy. And as you stretch that band, you can feel it pulling back, trying to get back to the original shape. Elastic potential energy is a result of changing the shape of an elastic object. Oh, that was a matching question, but there are the answers here. Fire, chemical potential energy. A slide or roller coaster, gravitational potential energy. And then a bow and arrow, archery, you're pulling back on that string, and that will shoot the arrow forward. All right, that's it for the first section of this physical science. I hope you had a little bit of fun learning about energy flow, and we'll learn more about that next time. But until then, Have a good day, great week, and I will see you guys later. Bye.